all the queuing models are represented by this Kendall's notation. In general, a Kendall's notation is denoted as within brackets P slash Q slash R, then close the brackets. There will be a colon. Again, open a bracket, X slash Y slash Z, close the brackets. In this, the first letter P denotes what is the arrival rates probability distribution. Then the second letter Q, it denotes what is the service rates probability distribution. Then this R denotes how many service channels are available in that particular model. Then your X denotes the Q discipline, or you can say service discipline, how the Q is serviced. Is it FIFO basis or LIFO basis or zero basis, whatever it is. Then Y denotes the number. Is there any restriction in the number of customers allowed in the system or not? If there is a restriction, then you generally put a letter called capital N. Otherwise, we put it as infinite if there is no restriction means. The last letter Z denotes the size of the calling source population, means the people who are coming and joining the queue, where do they come from? That particular population's size, whether it is known or unknown, and if it is known, how much, etc. So this is what is the general Kendall's notation. We will be denoting any type of queuing model in this fashion. Then we will see what are all the different notations being used in various queuing models. Small n, when we say, it is about the number of customers in the system. When we say system, it means that people who are already there in the queue and people who are getting already started getting the service together, put together, how many are there in the system. When you say M, it is only the number of customers in the queue. Capital C denotes the number of service channels or servers in the system. Lambda denotes arrival rate of customers, means how many customers per time period, whatever may be the time period, maybe hour or minute or whatever it is. Then mu denotes service rate of the server, in the sense a server, how many customers it can service in a period of time, in a specific period of time. Rho denotes, this is rho, symbol rho, it denotes utilization factor, means how good the service channel is being utilized. So that is calculated as lambda divided by mu. P suffix 0 is nothing but probability of having 0 customer in the system. Then P suffix n means probability of having n customers in the system. L suffix q means average number of customers waiting in the queue. We can also say this as queue length. L suffix s means average number of customers waiting in the system. Or we can say length of the system, length of the system. Capital M denotes Poisson distribution. Capital N denotes the maximum number of customers permitted in the system. GD, we can say, which is nothing but general discipline, or it's also can be said as first in, first out, or first come, first serve. Some points, what we need to keep it in mind while dealing with queuing models is that in most of the queuing models, the arrival rate as well as service rate are assumed to follow Poisson probability distribution. Or we can say the inter-arrival time and service time are said to follow exponential distribution. So when we consider inter-arrival time and arrival rate, these two are reciprocals. Similarly, service rate and service time are reciprocals to each other. And since arrival rate and service rate are considered to be following Poisson probability distribution, so in the Kendall's notation, the initial two letters P and Q will be replaced with capital M only. Number of servers, generally we deal with the problems where there is a single server or more than one server. So which we did, if it is more than one server, we denote it by capital C and then specifically mention what is the value of capital C. Again, in most of the models, the queue discipline followed is FIFO, This is discipline. Sorry, I made a mistake here. Then maximum number of customers permitted in the system is considered either a finite number or an infinite number. For example, if we consider a cinema theater, there you can't have infinite number of customers in the system. There will be finite number of customers only. So there you will come across with capital N. Maybe it is a cinema theater or it may be a restaurant. It will have a finite number. And in most of the cases, there are infinite number of customers are also permitted in the system. And then the population size of the calling source is generally assumed to be infinity. So it means based on all these points and assumptions, we will be studying about the following 4 models. First one is arrival rate and service rate following. In all these cases, arrival rate and service rate following a Poisson distribution. In the first model, service channel or server is only one server. And Q discipline in all the cases, it is FIFO basis. And the number of customers permitted in the system in this model is considered to be infinity. And in all the models, we consider the calling source, the population size of the calling source as infinity only in all the models. Second model, instead of one server, we will be studying about more than one server. So we put it as C. And in the third model, single server, but there is a restriction in the number of customers permitted in the system. The last model, number of servers is more than one. And also there is a restriction in the number of customers permitted in the system. So subsequently, in our subsequent video, we will be seeing about all these different models one by one.